Penuh kesungguhan Akademi YouTuber Malaysia Langkah laksana dengan jitu Penuh bervisi Guru Ayu Mencapai misi yang satu Permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, salam sejahtera and good afternoon everyone. Welcome to Pusat Tuition Academy YouTuber with joint venture of eDidik Malaysia and Gap Guru Malaysia. I am Mr. Pei. Currently, I am teaching at College Tingkatan 6 Tun Fatimah Melaka. I am the on-duty teacher for this week. So, for your information, Academic Tuber Panitia Physics is preparing for you 2 free online classes, which is DLP Form 4 class held on every Sunday, 2 o'clock during the fasting month. And another class will be Form 5 non-DLP, which will be also held on every Sunday, 5 p.m. And for Form 5 non-DLP class will be presented by Cikgu Iziang. So you may attend her class later on at about 5 p.m. And today, we are going to start our new chapter, Chapter 2, Force and Motion 1. In this chapter, there actually have about 8 subtopics you are going to learn. And for first subtopic, it will be 2.1, linear motion. In this subtopic, you are going to learn about 3 learning standards. And one more information I want to let you know, there will be about the e-link schedule for class today. It will be provided at the end of the lesson. And you may fill out the link with any email you are available. And you have to fill out within 30 minutes after the live of today. And okay, so without further ado, let us start our lesson today. So the lesson today will be estimate finish within 1 hour. Okay, so for first learning standard, you need to able to describe the type of linear motion of an object in the following state. So the first will be in stationary or rest condition, where the object are not going to move. And second condition, there will be uniform velocity. The third will be non-uniform velocity. Okay, so first, let us discuss what is the meanings of the linear motion. Okay, so linear motion is referring to the alternation or changes in an object position over a time. So that means the object will be changed from position A to position B at certain or specific time interval. So linear motion is movement of an object along a straight path or single direction. Okay, so the motion referring to the changes of position of an object over the time. Then the linear motion will specify the motion where object will be moved in a straight line. Okay, so here we have some example of linear motion you may observe in our daily life. So the first, a car driving on a straight road. You can look at this GIF. Then the second, a ball rolling down a hill is also showing one of the example of linear motion. Besides that, an elevator moving up and down is also another type of linear motion. Then third, a person walking in a straight line. Another example here will be a train moving along a straight track. Okay, so now let's continue with some of the physics terms you need to understand and memorize. Okay, so the linear motion can actually describe in the terms of distance, displacement, speed, velocity, and acceleration. Okay, so the first two physics terms we are going to discuss will be distance and displacement. Okay, so here, the distance, normally we're using the symbol d, and the displacement will be used as small letter s to represent. Okay, so what is the meanings of distance? Length of route covered by an object, or the distance between 2 points. Okay, so here you can look at the diagram. Okay, this diagram, we have 2 points, A and B. So A is the initial position, and then the B is the final position. Okay, so for example, here we have a dashed line, green dashed line. So you may see that if a person walking through the green dashed line here from A to B, you may see it covers all the route where the person moves, and showing that it is longer, right, compared to the straight dark line here. Okay, so the displacement, we just look at the route from the first position to the final position. Okay, so the definition will be like this. Shortest distance between the initial point, so will be A, and the final position in the specific direction. Okay, so here, for distance, there will be total path covered by the person, which showing by the green dashed line here. So it will be have a longer total distance here compared to the displacement. Okay, so the displacement, we just take the shortest distance between the initial and the final point. And here we need emphasize the direction. But for the distance, we don't need look at the direction. Okay, so that means that for the distance, its magnitude depends on the route covered by an object. So we just look at the total path covered by the person. For the displacement, its magnitude is a straight line distance between the initial position and the final position. So where I explained to you just now already. Okay, so as mentioned that the distance is only we take care about its magnitude, but no any direction will be we observe for distance. So it is a scalar quantity. Then for displacement is a vector quantity. So we need to know its magnitude together with direction. Okay, so here the next two physics terms you need to understand. There will be speed, velocity, and the acceleration. Okay, so for speed, we're using small letter v. The velocity is also the same. Okay, then the acceleration we're using symbol A. Okay, so first we just discuss the difference between the speed and velocity. Just like the distance and displacement, they are quite similar, but there has some difference when the distance is scalar quantity, while for the displacement will be vector quantity. Okay, so the same differences will be same between speed and velocity. Okay, so here first we need to know the definition for speed. So rate of change of distance travel. For velocity will be rate change of displacement. So the difference here will be speed referring to rate change of distance. For the velocity will be rate change of displacement. Okay, so again, just now I explained already, the distance will be cover all the route passed through by the person. Okay, then the displacement will be only the shortest path between the initial and final point. Okay, so here, this is the formula we use to determine the velocity. Okay, so D represents distance, T will be time. So this is the definition for the speed. Okay, so the rate referring to time taken. Okay, so for the speed, sometimes the question may ask about the average speed. So the formula you are going to use will be total distance traveled by an object over total time. For velocity, the formula will be almost the same. However, we change the distance to displacement. Okay, so the T here will be also referring to the time taken. Okay, so the average velocity is actually same as the formula we apply for determine the displacement, because the displacement cover the shorter path, which will be always the same. Okay, then the SI unit for both will be same, meter per second. The main difference here, there will be speed is a scalar quantity. We just need to know its magnitude. No any direction will be involved. Okay, however, for the velocity, it will be a vector quantity. Okay, so the direction of velocity will be following the direction of displacement. Okay. Okay, then now we go for the last term, acceleration. Okay, so the acceleration will be the rate change of velocity. So again, from the definition, okay, so you may form is formula where there will be V over T. Will be like this. Okay, so V over T, in more specific, it will be changes of velocity. So you need to know its final velocity together with initial velocity. So here the change of velocity will be final velocity minus initial velocity over the time taken. So this will be the formula you are going to apply for the calculation. Okay. Okay, so the unit SI will be meter per second square. Okay, because the unit for velocity will be meter per second. So here over second, final, we get meter per second square. Okay, so the acceleration is also a vector quantity. So the direction of the acceleration, so here supposed to be acceleration per Newton for Bm, and then here will be acceleration. Okay, it's the direction of displacement also lah. Okay. Okay, so we have finished already to understand the definition, formula going to apply, and some of the characteristics for the respective physics terms. Okay, so here, now we can apply the terms you learned just now to describe the type of motion. Okay, so here, actually, we have 3 types of motion. If you still remember the learning center 1, where you have to learn. So we'll discuss about the object in rest or stationary condition. Second, it will be in motion actually. Okay, in motion, we can classify to in moving in uniform velocity. Another, they will be non-uniform velocity. Okay, so let us discuss the rest or stationary motion first. Okay, so here, an object is considered to be at rest when its position relative to its surrounding remain unchanged over time. So that means that if the person is at A at 2 o'clock, after few minutes, example 2:05 p.m. So the person is still at the same position, same point, which is point A here. So that means person or the object considered at rest condition. Okay, so here we have one example. So for example, when a bus stops at bus station, just like the figure here, you see the bus here. So it can be considered at rest in relation to the bus station because the bus is still stopped at the same location. Okay. Okay, so that means that the velocity for the rest condition, the object velocity will be 0. Okay, so you can using the physics terms to describe the type of motion. Okay, then the next here is motion. Okay, just now the object is in rest condition. Now we discuss about the motion. So the motion we can classify to 2 types, just like I mentioned already, which will be uniform velocity, and another one there will be non-uniform velocity. Okay, so here, motion, that means the object is moving, is not at the same position, right? Okay, so an object is considered to be in motion if its position changes relative to its surrounding within a specific time interval. For example, just like use point A, right? So at 2 o'clock. Okay, sorry. Okay, I return to the slide. Okay, so here at 2 o'clock. So after 5 minutes, 2:05 p.m. So the person moved to point B. So here involve the changes relative to surrounding over a specific time interval. So we consider the object is moving or in motion condition. Okay, so here examples of motion. Just now I mentioned to you, we have 2 different types. The first will be uniform motion. Okay, so the uniform motion we are going to discuss here will be uniform speed and the uniform velocity. Okay, later we see what's different between these 2 motion. Okay, and then the next will be the non-uniform velocity, where consider as non-uniform velocity, just like its motion, right? Non-uniform motion, here will be non-uniform velocity, where can be classified to 2. Acceleration and deceleration. Okay, so generally the acceleration, that means the speed or the velocity of an object increases. Then the deceleration, there will be velocity decreases now. Okay, so the first uniform motion, where involve of uniform of speed and uniform of velocity, right? Okay, so now, number 1, when an object covers equal distance in equal time interval, so the motion is referred to as uniform motion. So you can look at this picture, right? So OA, we covering, the car cover the same distance, 4 meters. Okay, 4 meters in 2 seconds. So the next 4 to 8 meters is another 4 meter cover, and the duration is also 2 seconds. So that means with the equal distance in equal time interval, so the motion is considered uniform motion. Okay. Okay, so here, for example, if a car travels 4 meters, just like the figure here, in every 2 seconds, so it is in uniform motion. Okay, so here, first, uniform speed. Okay, what means by uniform speed? So the speed that remains the same in magnitude, regardless of its direction. So that means if the car moving from O to A, 4 meters in 2 seconds, which is to forward position or right position. So if I say another second go to A to back to O again, 4 meters in 2 seconds. So here involve same magnitude, different direction. So we still consider the motion here is under uniform speed, although the direction is different already. Okay. Okay, then the next, it will be uniform velocity. Okay, so uniform velocity, velocity that remain the same in magnitude and in direction. So you can look at this figure. So the car moving from A to B in 1 second, and the magnitude is the same together with direction is. So it considered as uniform velocity. However, if the car move back from D to C in another 1 second, so although the time taken and the magnitude involved is same, but the direction is go to west already. So that means that it cannot be considered as uniform velocity anymore because here involve direction changes. However, the case can consider as uniform speed. Okay, so this is the difference between the uniform speed and uniform velocity. Okay, so the uniform velocity where not involve the changes of magnitude of velocity, so we can consider as zero acceleration. So that means the velocity of the car is always the same. Example, 100 km per hour along the journey. Okay, so now we go for non-uniform motion. So where involve of acceleration and deceleration. Okay, so for the non-uniform motion, okay, so when an object cover an equal distance in equal time interval or equal distance but unequal time interval, so the motion considered as non-uniform motion. Okay, so the figure here involves the car travel from city A to city B. Okay, so here involve 90 km, right? Okay, so here the car from initial position, I put as A lah. Okay, so to point 1. So here involve same or equal distance, but the time taken from A to point 1 and then point 1 to point 2, the time interval is different. So here, that means that it considered as not uniform motion. Will be the case for second example, right? Equal distance, here is showing equal distance. However, the time interval is different. So this is considered as the example for non-uniform motion. Okay, so another here explain about unequal distance but same time interval. That means from point A to B, here maybe cover 40 km. Okay, so here take about 1 hour like example. So from B to C, 20 km, take about 1 hour also. So here with equal time interval but unequal distance. So here also showing that this is a non-uniform motion. Okay. Okay, so for number 2, an object has a non-uniform velocity if the direction of motion changes or the motion is not linear. Okay, so here direction changes also considered as non-uniform velocity, where we discussed just now. If the car moving to the right initially, then it reverses to left side, although it involves the same magnitude or time interval, but here is not able to consider as uniform velocity. Okay, so the second case, the magnitude of its velocity changes. So for this case, the changes here will be the magnitude. Okay, so to fulfill the requirement for uniform velocity, the direction and the magnitude must be equal lah. Okay, so now here, examples of non-uniform velocity. The first will be acceleration. So the acceleration can also known as velocity increases uniformly. Okay, so here you can look at this figure. Okay, so the car at the first second is moved with 20 meters. Then after that, the car for the next 30 meters is involve the same time interval. So that means here the velocity is increases. So the distance between two consecutive image increases. You can see this figure, right? This is okay, so this is the first. This is the second. So it's showing that the increase in the distance. Okay, so that means that the velocity is increases. And the car is accelerate. Okay, then for the second case, it will be velocity decreases uniformly, or we can know as deceleration. So the car slower lah. Okay, becomes slower. Initially it's fast. Then next time interval slow. So this is deceleration. Okay, so the distance between two consecutive image decreases. You see, here involve 30 meters, then the distance decreases to 20. So the car velocity is decreasing, and this means that the car is decelerating. Okay, so this is the example of non-uniform velocity and non-uniform motion. You can also keep it as a non-uniform velocity. The first will be increasing, another one, the bottom one, there will be velocity decreases uniformly. Okay. Okay, then the next will be learning standard 2. Okay, just now we already understand the terms of the distance, displacement, speed, velocity, and acceleration and deceleration. Okay, we also discussed already the formula are going to use for certain type of problem solving. So this is the learning standard 2 where you should able to use the formula to solve some problem solving. Okay, so now we straight away go for our first question. Okay, so we apply the formula you learned already at learning standard 1. Okay, so here Ali draw for a car. Home starting from point A. Point A will be here. Here, A, initial point. So the diagram shows the route taken by Ali to return home. So the final point will be here. Initial point is F. Is A, initial point. Yeah? So the final point, there will be F. Okay, so the question asks about the distance and the displacement of Ali back to home. Okay, so the distance is cover all the route traveled by the car. That means it will be A to B, B to C, C to E, and then E to F. Okay, so we just total out the whole distance. So 200 plus 500 plus 600 and plus another 200. So you get 1,500 meters. Okay, so this is how we get the distance for this question. Okay, so how about the displacement? Okay, so displacement, we just consider the first point and the last point. Okay, so here, the displacement will be shorter path between the initial point and the final point. Okay, so it will be represented with green color arrow here. Okay, so that means we need to find the AV, right? B will be here. So AV vertical is 200 plus 600. Okay, so you get 800 meters. Okay, and then we have to get horizontal line here. This line. Okay, so here we cover 200 with 500. So here will be 700. And then we just using theorem Pythagoras. So the displacement is the hypotenuse for this right angle triangle. Okay, so here will be 800 square plus 700 square. Okay, so you may get your answer 1,063.01 meter. So your answer must be minimum 2 decimal places together with correct unit. If you not give minimum 2 decimal places, answer will be wrong. Consider wrong. If you give 2 decimal places without unit, you also consider wrong. Oh, please remember that you must give minimum 2 decimal places with correct unit for your answer. Okay, then here B will be the continue question for the same problem solving. Okay, so what is the average speed of a car in km per hour if the time taken to get home is 10 minutes? Okay, so you must change your unit. Just now we have meter, right? Change to km. And then the 10 minutes you have to change to hour. Okay, so here average speed formula will be total distance over total time. So total distance just now we get already from answer in A. So where will be 1,500? We add on 200, 500, 600, and 200. Okay, so we get 1,500. So you have to change to km. So you divide 1,000. Okay, and then the time taken here will be 2 minutes. Sorry, here supposed to be 2 minutes. So I have typo error for English person. It's 2 minutes. Okay, so 2 minutes change to hour, you have to divide 60. Okay, so end up you get 45. So again, you have to give km per hour. Okay, so when we get exactly whole numbers, you don't need to give 2 decimal places as 00 lah. You can just give whole number. Okay, so this is how we get average speed, where the formula you learn through the Lesson 71 already. Okay, then the second. Okay, so the second, actually the question, I think I missed out here. Besides the question asked about the average speed, okay, another question here will be the average velocity. So here I just want to let you understand the difference between the average speed and average velocity. Okay, so here we're using displacement over time taken. So displacement just now we also get ready the answer in A. So where will be 1,063.01. Again, you have to divide 1,000. So time taken is the same. So here we get 31.89 km per hour. So minimum, just like I mentioned to you, answer must be in 2 decimal places and correct unit. Okay, so this will be the difference between the average speed and average velocity. Okay, so the question number 2 here, we are going to apply the formula you learn at Learning Center 1 also is related to acceleration. Okay, so here, let us go through the question together. So a car starts from rest and increases his velocity at a constant rate until he reaches a velocity of 100 in 10 seconds. Okay, so here, the question in direct tell you already, the rest for initial velocity, we're using symbol U. So where will be equal to 0 meter per second. And then here, 100 meter per second referring to V, final velocity. Then 10 seconds referring to T. So the question asks you about the average acceleration will be A. Okay, so here, the formula we are going to apply will be this, right? V minus U over T. So you just substitute all the value given. Okay, so here is 100 minus 0 over 10. So you may get your answer 10 meter per second square. Okay, so remember to give the correct unit. Okay, so here will be the discussion about a ticker timer. Okay, a ticker timer. Okay, so the first one. Okay, so ticker timer fitted with ticker tape as shown in diagram is used to investigate the linear motion of object in the laboratory. Okay, so just now we explained already the 5 physics term you learn at 2.1. Where will be distance, displacement, velocity, speed, acceleration. Okay, so how we can know their value or their magnitude? So you may get the linear motion or the magnitude of the motion through this device, or we know as a ticker timer. Okay, if you look at this figure, okay, so this is the ticker timer. So where it has vibrating plate at here. Okay, and then the ticker timer will be connected to alternating power supply. Okay, and then here we have a carbon paper, and here we study the motion where the dot made by the vibrating plate. Okay, so we have to study lah. So you have to understand the dot show in the ticker tab is actually what type of motion. Okay, so here pull by moving object. Okay, so this is the condition of the object you are going to study. So later on we can go through one activity 2.1 where started clearly in your textbook already. Okay, so that means that the first sentence just tell you we're using ticker timer to study the linear motion. Okay, linear motion of an object. Okay, so the linear motion just how we explained already. We have the linear motion where in rest condition, where will be next uniform velocity. Another one, there will be non-uniform velocity. So what is the appearance of the dot on the ticker tab? So this is what you actually need to learn in this Berlin Standard 2. Okay, so here this is number 2 lah. Okay, so a ticker timer is connected to a 50 Hertz alternating current power supply. So here you can look at this figure. Just like I explained to you. So the ticker timer will be connected to power supply. So the power supply is together with the 50 Hertz alternating current. Okay, so causing the vibrating plate to vibrate 50 times every second when turned on. So the 50 Hertz, that means that the vibrating plate will be vibrate 50 times. Okay, so the vibration plate actually, the cross-section area will be like this. So here we have a pin. Okay, so the carbon is on top. Here is a carbon paper. You just imagine this is a vibrating plate. Normally it's an iron strip. Okay, so here vibrating plate. So vibrating plate vibrate, that means the plate will be moving up and down like this moving up and down. Okay, so will be hits the surface of carbon. So this is a carbon paper. Okay, so underneath or below the paper, carbon paper, it will be the ticker tab. So that means that when the ticker tab moving, so when the vibrating plate vibrate, so it may form dot on the ticker tab. So now we want to study the dot made by the vibrating plate due to the motion of an object. Okay. Okay, so here in 1 second, 50 dots are made. So because the current with 50 Hertz, so it will be form 50 dots in 1 second. If I say the current is together with 20 Hertz, so that means that there will be only 20 dots will be made in 1 second. However, our current is actually in the 50 Hertz already. So here, if the question not tell you anything, so there will be no any changes now. We're assuming that it will be 50 Hertz. Okay, so that means that the 1 second, there will be 50 dots will be able to make on the ticker tab. So that means the vibration is very, very fast. Okay, so which means that the time interval between two consecutive dots is 0.02. So what means like consecutive dot? Okay, so just now I explained to you already. So how the dot is made. So here will be due to the vibration of the vibrating plate. Okay, so here the first dot, this will be second dot. Okay, so to make two consecutive dots, so we need 0.02 seconds. If the ticker timer is connected to vibrating bar, connected to 50 hertz alternating current power supply, which is 1/50. Okay, so here will be the picture tell you 1 tick will be this lah. Okay, so tick is defined as a time interval between two consecutive dots. Okay, so just now I explained already. So the two dot will be need 0.02 second to form, right? Okay, so two dot, that means that is 1 tick. Here, this will be 1 tick. Okay, so that means the time taken for 1 tick will be 1/50, which is equivalent to 0.02 seconds. Okay, so here a ticker tag records the displacement of the moving object as well as the time taken. Okay, so you can see through this figure. So here starting point will be here, initial point. If I say the object stop here, so this will be last point. So distance between the first dot and last dot, it will be displacement. Okay, and then time taken, you also can determine through the ticker tag. Because here, just how we mentioned, 1 dot, 0.02. 2 dot, you need to add on another 0.02. Third dot, 0.02. Hey, tick, sorry, not dot, tick. This one is first tick. This one second, third, fourth. So here involve 4 tick. 4 times 0.02. So you know already lah. So the time taken from the first point to last point will be 0.08 seconds. Okay. So after we get distance, displacement and time taken, so we can calculate velocity and then the acceleration by using a formula. So here you may refer to your textbook, activity 2.1. Page 32 will be this actually, but I'm not going to detail for this experiment. You can look at the end of the experiment. Okay, so here the activity is actually want to study displacement, velocity, acceleration of a trolley by using the ticker tag. Okay, so here if you look at the figure 2.1, so you can see the object is actually moving down. Okay, so here we want to study the velocity, uniform velocity case, and also the acceleration. So that means when the trolley moving down, so we expected the speed of the trolley increases, acceleration. Okay, then if you look at the figure 2.13, the trolley is thrown up, right? So the trolley had to overcome the gravitational pull together with friction on the surface. So the speed will be decreases. So that means the figure 2.13, we actually want to study the deceleration condition. And then after the experiment, you can observe what's the difference of the dot appearing on the ticker tag for both cases now. Okay, so here, as I mentioned, the first figure 2.12 is actually tell you the acceleration case, and then the figure 2.13 is actually the deceleration. Okay, so now you know already how the concept for the ticker tag timer. Okay, so to get the dot on the ticker tag ready. Okay, so now how we can identify the motion. Okay, so here study the type of linear motion through observation and calculation on the dot appearing on the ticker tag. Okay, so here basically here there will be 3 types of linear motion we are going to discuss in your Form 4 syllabus. Okay, so here first will be the uniform velocity. Okay, so the uniform velocity, that means that the velocity is maintained the same. Just like I mentioned to you, right? Example, a car moving on the road with 100 km per hour along the time interval. So there will be no any increases or decreases of speed. Okay, so here, the ticker tag will be showing or appearing like this. You can see here. So all the dot on the ticker tag, this is the ticker tag. So this is a dot. So the distance between 2 dots is always the same. So that means here, 2 dots tell us about the time interval. Then the distance between 2 dots is a distance between 2 points, right? So when distance between 2 points and the time interval is the same, so that means that this is in uniform velocity. If you still remember the definition we explained just now, okay? Okay, so the arrow showing that the object is moving to left side, right? So that means that this is the initial velocity. Here, this will be the final velocity. Okay, so you must look at the arrow. If the arrow is at right side, here will be the initial, here will be the final. Okay, so you must observe clearly for your question, especially when the question asks you to calculate. Okay, so here I mentioned already, so because the arrow is to left, so this is the initial point. First point will be this, first dot. Okay, so this will be first tick. So here will be U, then here will be V. Okay, so here, the distance between 2 consecutive dots are same. So this is the observation in the ticker tag in this figure. So where you can conclude that this is the uniform velocity. Okay, besides, we straight away look at the ticker tag. Actually, the ticker tag where you get is very long. You have a lot of dot on the ticker tag. Okay, so here you can actually cut. For example, here, how many tick we have? 1, 2, 3, 4, 5. Okay, so you can cut 5 tick. 1, 2, 3, 4, 5. For example, here. So if this is the direction of motion, this will be the first strips. So another 5 tick will be the second strips, until the last strip will be here. Okay, so this is known as the chart. Okay, so this is a chart. Okay, so from here, if you observe the chart where length versus time taken, so you can see all the length of the ticker tag is the same. So here also, this also can tell you that this is in uniform velocity. Okay, so this is the first strips where represent the initial velocity, and then the last strip will be the final velocity. Okay, so the way how we calculate the initial velocity for the strips and the chart is different. Later on, I'll tell you how to calculate. Okay, so here is an example of the constant velocity or uniform velocity motion. Okay, so here you can see the distance between 2 consecutive dots is same. This one tells us already this is the constant velocity, and the distance between 2 dots here is very small, you see. So that means that the motion of an object is actually very slow compared to case B here, you see. Here again, first, the distance between 2 consecutive dot is the same, but the distance between the dot is bigger compared to case B. So we can conclude that the case B is moving constant velocity but higher speed. Okay, so this is how you can compare the speed on the dot appearing on the ticker tag. Okay, so now we go for uniform acceleration. Okay, so uniform acceleration we also can know as velocity increases uniformly. Just now I also tell you already. Okay, so for this case, you can see the dot appearing on the strips. Okay, you can see we need to know the direction. So here, this will be initial tick. Here will be the final tick. So if you compare initial tick and final tick, so the distance between two consecutive dots is actually increases. Okay, so here tell us already. So initial moving slow. Then final is fast. So this tells us the velocity is increases uniformly. And this is also can known as acceleration. Okay, so here the distance between two consecutive dots increases uniformly. Okay, so this is U and this is V lah. Okay, so the second, again, you can observe the chart. So where the chart showing the length of the strips increases uniformly, right? Okay, so how to paste the strips again, just like I explained to you. So here, if you look at the numbers of tick for each strip will be the same. Actually, 1, 2, 3, 4, 5. All must be using the same numbers of ticks. So here will be 5. So that means the first strips will be the first 5 tick. You cut, you paste here. Then the next 5, 1, 2, 3, 4, 5. You cut, you paste here until the final. Okay, so that means that the first strip is actually represent the initial velocity here. Then last strip will be tell us the final velocity of the motion of an object. Okay, then the last case here will be the uniform deceleration. That means that the velocity decreases uniformly. Okay, so here will be the appearance of the dot on the ticker tag. So here again, the arrow is here. This is the initial velocity of the first tick. Here will be the last tick, V. So you can see the initial distance between two consecutive dots is bigger compared to final. So here is moving at fast condition. The last will be moving slow. So from fast to slow, so the velocity decreases, or we can know as deceleration. Okay. Okay, so here, okay, so the distance between two consecutive dots decreases uniformly, you see. So this is how you describe. So if I say the question asks you, what is the motion shown by the strips here? Shown by the ticker tag here. So you can conclude that this is a velocity decreases uniformly or deceleration. Reason, because the distance between two consecutive dots decreases uniformly. Okay. Okay, then here will be the U, just like I explained already. Here will be V, final velocity. Okay, so here you may also determine the type of motion through the chart. Again, so here we can see the length of the strips, actually the length of the ticker tag here is decreases uniformly. So again, here, okay, so again here, this is U, first strips, this is V. Okay, so how you can cut the strip here, just now I also mentioned to you. So here, if you look at here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tick. So again here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here will be a 10 tick. You cut, then this will become your first strips already. Okay, so this is how we identify the type of motion through the ticker tag. Okay, so now we go through together the calculation method of velocity, acceleration, or linear motion. Okay, so here, just now we have a strip already. For the first case, we have a uniform velocity, right? Here you see the two consecutive distance is equal, right? Actually, this strip tells us this is a uniform velocity. So how we can determine its velocity? Okay, so here, first you need to determine the time taken. Okay, so time taken for the tick. So here, time taken for one tick is 0.02 seconds. Just how we also go through it. So here we have how many tick? 1, 2, 3, 4, 5, right? So 5 tick times 0.02 will be the way how we get the time taken. Okay, so here, numbers of tick for this case will be 5. Time taken for one tick will be 0.02. Okay, because of the frequency of the current power supply is 50 Hertz, that we assuming that. Okay, so here just now I explained to you already. Okay, so we have 5 tick. Okay, so we're using formula 5 tick times 1 time taken for one tick 0.02. So the time taken here will be 0.10 seconds. Okay, then the second step, there will be determine the displacement. Okay, so the displacement is actually showing in the figure already. The first initial point to final point. So here will be 9 cm. Okay, so here the displacement between the initial and the final point is 9 cm. So the displacement formula we also learned already. So where will be displacement against time? So you just substitute the value 9 cm for displacement, 0.10 second for time taken. So and now you get 90 cm per second. Okay, so you must give correct unit. If the question give you meter, then you give meter per second. Okay, so this is the way how we determine the velocity. Okay, so next will be acceleration. Okay, so the acceleration, we have two different cases where we straight away using the long ticker tag. Another will be changed to we cut, separate the ticker tag and paste on the graph. Okay, so the first determine acceleration, this is the formula we are going to use. You need to find out the U, find out the V and T. Okay, so this is the strips. Okay, so here you see the direction of arrow is to here. So that means that this is the first tick. Okay, so this is the first tick. So will be represent the U, initial velocity. So the arrow is very important for you to determine which part is initial point or the initial velocity. So the last tick will be this. Okay, so here this will be V, you need to determine. Okay. Okay, so here I tell you already, this is U lah, you need to find out. And then here will be the V, you need to find out. Okay, so the first step, you have to find out the initial velocity. Okay, so initial velocity formula will be displacement against time. So the displacement for the first tick will be 3. Time taken for one tick is 0.02 seconds. Just now we also go through it. So the initial velocity will be S1, because here we have how many ticks? 1, 2, 3, 4, 5, 6. So I put 1 because of the first tick. Okay, so we substitute 3 cm over 0.02. We get 150 cm per cm. Okay, then the next step will be find out the final velocity will be here. The distance 0.5. Time taken again, one tick will be 0.02. So you get 25 cm per second. Okay, then after we get this V and U, now we want to get the time interval. Okay, so please take note for this. Okay, so to get time interval, Now you see, determine the time interval for the change in the velocity t. Okay, so here, we need to know total tick here. 1, 2, 3, 4, 5, 6. Okay. So here, first tick to second tick, we consider for the first time interval. Or first time interval. Then second to third will be the second. So here 1, 2, here will be 3, 4, 5. So here will be 5. So that means that actually you can using total tick minus 1 will be 5, right? For this case, times time taken for one tick. So you'll get the time interval 0.1 second. Or remember, the time interval for acceleration, you must minus 1. Or because they take first tick to second tick as one time interval. Okay, so end out, you must minus 1. Okay, then after that, the acceleration, you just apply this formula. Okay, we substitute all the value we get already. Initial 150, final 25 over 10 seconds. So you get answer negative 125, negative 1,250. Okay, so negative tell us that this is actually deceleration, right? You see, initial distance is longer, so this is fast. Final is lower, so the velocity decreases. This is a case of deceleration. Okay, then the next will be also determine the acceleration, but is in chart, ticker tape chart. Okay, so we cut the ticker tape according to the numbers of tick we want. Must same for all ticker tape. So here 1, 2, 3, 4, 5, all will be the same. You cannot give different numbers of tick for your calculation. Okay, so here again we're using V minus U over T. So our U will be here. This is our first strips. And then this will be our V. Okay. Okay, so here this is U, and here will be the last strip will be V. Okay, so how we get our U? First step, again, we get initial velocity. So initial velocity, we want this displacement here will be 2, right? Time taken, just how we mentioned, we go through it will be total 5 tick, right? Okay, so 5 tick times 0.02 will be the time taken. 5 tick, So here, displacement 2, time taken 5 tick, 1 tick 0.02. So you get 20 cm per second for your initial velocity. Okay, so for final velocity, the displacement will be 10. Right, 10. Okay, then numbers of tick is always the same. 5 times 0.02. Okay, so you get 100 cm per second. Okay, so this is V and U. Okay, so the time interval, just like I tell you, we need to minus 1, right? So how to minus 1 here? Okay, so here time interval. Okay, so here will be 5 minus 1. So how we get 5 minus 1? So here we have total numbers of strip 1, 2, 3, 4, 5. We have to minus 1. Then one strip's time taken will be 5 tick, right? So they will be 5 times 0.02. So again, the time interval, we take first strip to second strip will be the first. Second to third will be second, and others. So total we have 4 only. So here you see 5 minus 1. So you just look at how many strips based on the chart, minus 1. This will be the how we get 4. Then 5, that means that each strip will be consist of how many ticks. Okay, so after that you get 0.04. And then you substitute, determine the acceleration, substitute the value in the formula. 100 minus 20 over 0.4. So you get 200 cm per second square. Okay, so here you get positive value because shorter strip at the beginning tell us that this is slow. Longer strips tell us that this is fast. Or you can look at the tick also. Initial, the 2 consecutive distance is short. So tell us this is slow. Then final, two consecutive distance is longer, so become faster lah. Slow to fast, this is deceleration. So you must able to know that your value should be positive lah. If you get negative, there will be something wrong with it. Okay. Okay, so before we continue discussion for partial question related to Learning Center 2, so let us take a break first. Okay, we come back another 30 seconds.
Penuh kesungguhan Akademi YouTuber Malaysia Rangka laksana dengan jitu Penuh bervisi guru ayu Mencapai misi yang satu Permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link SPL KPM akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, so welcome back everyone. Okay, so let us go through the related question for Learning Center 2. Okay, so here is actually the partial question of 2016 now. Okay, so let us go through the question together first. So diagram 1 shows a ticker tag with 5 ticks. Okay, so here 5 ticks are 1, 2, 3, 4, 5. Okay. Obtained from an experiment. Okay, so here the question, 1 tick is a 10 seconds from P. So P will be here. So to another point. So where is the point? So 1 tick just now we explained already, will be here. So here will be Q lah. Okay, so it's actually quite easy, right? If I say the question start with point R, so that means the next one will be S lah, you want. This is a very simple partial question, very related to our Learning Center 2 today. Okay, then the next question. Okay, so the ticker tag can be analyzed to determine the. Okay, so just now we also explained already the ticker tag able to let us to determine the 5 physics terms, right? So first, there will be distance. Second, speed. Third, we can get also the velocity. We can get acceleration, right? Okay, so it's not related to force and momentum now. So answer very clear that this will be the first one, right? This is the type of question I'm going to ask. Okay, then the next here will be C1. Okay, so what is the type of motion shown by the ticker tag? Okay, just now I tell you already. So we have how many type of motion? We have rest condition, we have uniform velocity, acceleration, deceleration, right? Okay, so from here, you can see. So here, if you have the answer, you can actually show me at the chat room now. Okay, so here PQ, QR. So you can see the distance between 2 consecutive distance is always the same, right? So here, this is very clear that this will be the uniform velocity, because the distance and time is the same. So here, uniform velocity, or you can give the answer as 0 acceleration. Okay, so the reason, what's the reason? Actually, I tell you already. So this is the way how you judge, right? Because of the 2 consecutive distance is always the same. Okay, so answer, distance between any 2 consecutive dot is the same. PQ, QR, RS, ST, or TU, all is the same. Okay, so now we go for our next question. Is a partial question of 2019. Okay, so diagram 5.1 and 5.2 shows 2 ticker tags with different length produced by the motion of 2 trolleys. Okay, so here, the question number 5 normally will be type of conception question, where the question will give you 2 diagrams and ask you to compare. Okay, so here the first question asks you what is the length. Okay, so the length is actually distance between 2 dots, right? This one. Okay, so this will be the meanings. Normally the first question will become with definition. Okay, so you have to memorize the definition. Okay, then second, okay, so here is a comparison. If you not do any revision, actually you can do also if you know the answering technique. Okay, so here, based on the diagram 5.1 and 5.2, these two diagram, compare the numbers of tick. Numbers of tick here. 1, 2, 3, 4, 5. Here, second diagram 1, 2, 3, 4, 5, right? You see, both diagram tell us same. So here you have to give the numbers of tick in diagram 5.1 equal to 5.2. Okay, you can using the mathematics symbol for your answer, A1. So this will be the way how you answer for conception question. You have to write everything, because here the 3 marks together. If separate 1 mark, you can straight away give diagram 5.1 equal to 5.2. But here you see combined. So you have to give long answer. The numbers of tick in diagram 5.1 is equal to 5.2. Okay, how about the length? See the length. Actually, it's very clear now. Here. Or you can straight away look at the length, total length of the ticker tape here. So here 5.1 is shorter, right? So the length of the ticker tape in diagram 5.1 is smaller than 5.2. Will be like this. Length of the ticker tape in diagram 5.1 is smaller, you see, less than 5.2. You can using mathematics symbol for your answer. Okay, then the average speed. Okay, so the speed, you can look at the distance between two consecutive dots, right? So you can see 5.2 is longer, 5.1 is shorter. So shorter must be slower, right? So average speed 5.1 will be smaller or less than 5.2. Okay, so this will be E. Average speed in diagram 5.1 is smaller than 5.2. So you can using this symbol to show your answer. Okay, then C. So using your answer in 3B here to give the relationship between the length of the ticker tape and average speed. Okay, you can see when the length increase, speed also increase, right? You can observe one of the diagram. Or vice versa here. Okay, so here, the longer the length of the ticker tape, the higher the average speed. So this is how you answer the conception question. Actually, you can get the full marks, right? If let's say you not do any revision. Okay, so the next question will be theory. So here, diagram 5.23 shows the ticker tape chart. Will be this chart produced from a motion of a trolley. Okay, so based on the diagram 5.3, explain the type of motion from W to Y. So you can see W to Y. Okay, so here 3 marks normally will be 3 points, but here we can observe from W to X, the strip length become longer and longer, right? So that means that W to X is actually velocity increases or accelerate. Or from W to X, uniform acceleration or velocity increases uniformly. Okay, then for X to Y, the length of the tape is the same. So tell us that this is in uniform velocity, right? From X to Y. So is constant velocity, uniform velocity, or another term will be acceleration is 0. This is the way how you describe the motion. Okay, then another question related to Learning Center 2 will be this objective question. It's a past question of 2017. Okay, so let us go through the question. Diagram 3 shows a ticker tape for the motion of an object. Okay, so here arrow is here. So that means that here will be the initial velocity. Here will be final. So you can see initial, longer, this will be fast. Final is shorter, here will be slow. From fast to slow, there will be decelerate, right? Okay, so this is U. Longer distance tell us this is fast motion. This is what I explained already. Okay, then V will be here. Shorter distance here. Tell us this is slow motion now. So from fast to slow, this is decelerate. So which option here is correct? The first, the object accelerate, wrong because it decelerate. So the object accelerate, then constant velocity. Okay, constant velocity. Correct, you see. So the distance at the final part is actually always the same. Tell us that the motion is decelerate until here. Then start to have constant velocity from this point. Okay, so answer should be B lah. Okay, then C, object move with constant velocity, then accelerate. Wrong already lah. That means that the student might reverse V to here already, but actually it's wrong lah. You have to look at the arrow. So the object move with constant velocity, then decelerate also wrong lah, because we start with decelerate first. So answer very clear, there will be B. Okay. Okay, so now we go for our last learning standard A1. So I think another 10 minutes we can finish the lesson today lah. Okay, so here the last learning standard here will be problem solving involving the linear motion using equation. Okay, so here we have 4 equations are going to learn here. Okay, so here we learn linear. Okay, so here solving here got typo. So solving problem of linear motion using linear motion equation. Okay, so here we have 4 equations. Okay, so first will be V equal to U plus AT. So V will be final velocity. U will be initial velocity. Then A will be acceleration. T will be time. This is the first. So how you get this equation, you can look at the textbook. However, how we derive the equation will be not asked during the exam. So you just apply the equation. Okay, so number 2 will be this S equal to 1 over 2 U plus V times T. So S represents displacement now. And the third equation here will be S equal to UT plus 1 over 2 AT squared. So all the symbol already started here. And we already explained the symbol at the learning center 1. Okay, then the last linear equation involved will be V squared equal to U squared plus 2S lah. Okay, so here the next question here, let us apply these 4 equations in our problem solving. Okay, so here, question number 6. A car moves with velocity 40 to east and speed up uniformly to velocity 60. Okay, so here, please give the symbol. So here, initial velocity will be U. Final velocity here will be V lah. In 4 seconds, this will be T. So calculate the acceleration. The question asks about A. Okay, so what formula you are doing? What equation you supposed to use lah now? Okay, so here question give you U, V, and T. Asks you to find out A. So the most suitable equation will be this lah. V equal to U plus AT. Or you just need to substitute into the equation. Okay, so with this 60 equal to 40 plus A4, right? So you rearrange, you may get your A will be 5 meters per second squared. Or it's actually very easy for the last learning standards. You just need to identify the value given with appropriate or respective symbol. Then you choose the most suitable equation. Put all value, you make it already the answer. Okay, then here will be the last question for today's lesson. Okay, so a motorcycle traveling with velocity 20 meters per second. So here, suppose will be our U. Okay, so accelerate. Okay, so here at the rate of 4.5 meter per second square. So this is the A, right? Because we can observe the unit meter per second square represent acceleration. Okay, then the time taken here will be 20. So what is the displacement? So the question asks about S, right? A1. Okay, so this is what the value given by the question. So we choose the most suitable equation. Okay, so here I choose this equation. So where the question asks about S, U we substitute with 20, T is 20 also, given by the question. A, 4.5. T squared. Press your calculator. You may get the answer is 1,300 meters. Okay, I think the learning center 3 is actually very easy, right? Okay, so we already come to the end of the lesson today. Okay, so thank you very much for everyone who joined my lesson today. Okay, so please click like and share the link of the lesson today for your friends so that there will be more of your friends able to get benefits from my lesson. Okay, then now I want to share to you the e-link schedule for today's lesson. Okay, so please refer the link e-schedule for today's lesson in the chat room. I already posted to the chat room. Again, advise you to fill out to complete the form within 30 minutes. Okay, just after the live lesson end today. Okay, you may fill out with any email. Okay, so remember to join our next physics class. So where will be held on a Friday, 2 o'clock for DLP Form 4. And then the non-DLP Form 5 will be soon, where will be conducted at 5 p.m. Today will be presented by Jeku Iziam. Okay, so I think this will be the all sharing for subtopic of 2.1 today. Okay, so see you all again for next lesson. Okay, so bye-bye.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi YouTuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi YouTuber Malaysia, berpadu bersatu keluarga ayu, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi YouTuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha ayu, capai kecemerlangan, berpadu ayu, cipta kegemilangan, bersatu ayu, bina wadah terbilang, terus berjaya bersama ayu.
Berusaha ayu, capai kecemerlangan, berpadu ayu, cipta kegemilangan, bersatu ayu, bina wadah terbilang, terus berjaya bersama ayu.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi YouTuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.